So that is your, yeah. So that is your goal. Got it.
Yes, sir.
When I say accurate measurement, you need to have a proper measurement system. You need to have proper measurement system. Yes, we call our current performance as baseline. There are different ways of measuring our baseline. If it is a process capability improvement project, then you can measure the process capability in terms of DPMO, which we already discussed on day number 1.
Yes.
Defects per million opportunities.
Million opportunities.
You can also prefer to use the other metrics. The other metrics are yield, isn't it? Traditional yield. Have you discussed on it?
Yield.
No?
No, no, no.
No.
Okay. So that means I understand you have only discussed up to measurement system validation.
Yes.
Yes,
Yes.
sir.
Measurement system validation. So
Yes, sir.
any measure, first of all, what is a measurement system? System means it contains some elements inside.
Your voice is
So it
echoing,
is
sir.
basically
Intermediate.
No, my voice cannot echo now because I am not using the other device. Maybe I completely.
Okay, now it's fine.
Now it is okay?
Okay.
Okay. Okay. So measurement system means it should have elements inside. What are the elements inside a measurement system? The measuring instrument. Measuring
yes,
instrument
sir.
is part of
With
your measurement
specific
system.
limits.
The person who is collecting the data, he is also part of the measurement system. Am I right?
Yes.
Yes, sir.
The characteristics that you are trying to measure, or the product characteristics that you are trying to measure, it is diameter sometimes, length sometimes, it is the lead time, or it is, any characteristics that you want to measure. That itself is part of the measurement system. The instruction that is given to you on how to measure, which is known as operational definition, and the environment under which you collect the data. How many elements? 5 elements.
5.
The measuring instrument, the person who is collecting the data, we will call him as appraiser, the characteristics that is getting measured, the operational definition, and the environment. If there is a problem with your data, it means there is a problem with one of these elements. If there is a problem in your data, then there is a problem with one of your elements. You need to take the right action. Otherwise, your data will give inaccurate readings. How do you measure the inaccuracy? Have you learned
By
anything?
repeatability and repeatability.
See, with the measurement error, there are 2 things you all have to have a clarity. One is inaccuracy, another one is inconsistency. One is inaccuracy, the other one is inconsistency. Inconsistency or consistency comes if you repeat anything, isn't it? If you measure some characteristics multiple times, then only the need for the consistency comes, isn't it? So why should we measure multiple times? We measure multiple times to make our readings more and more accurate. Am I right? That is our intention.
Yes.
In your school, college, everywhere, wherever you did experiment, you might have noticed your teacher and your professor advising you to repeat certain experiment 2-3 times. The intention behind is to make your data more and more accurate. If you repeat some experiment 2 to 3 times, you know what will you do after that? You will calculate average out of it. Am I right?
Yes.
When I take average, the bias will reduce at least to half of it. To reduce the bias only, we did multiple experiments, and then the average is used for further purpose. Hope all of you understand. All right. But even though we take the average, try to minimize the bias, but still due to inconsistency, some amount of inaccuracy will be there. Am I right? Due to inconsistency, some amount of error will be there. The error due to inconsistencies are known as repeatability error and reproducibility error. Repeatability error and reproducibility error. But the error due to inaccuracy is known as bias. Am I correct? Is known as bias.
Correct. Bias.
So imagine right now the time is, what is the time now? 7?
12.
12.
7:12. So all of you are able to give me a very accurate reading of time. 7:12 is the correct time, and you all have told me
Yes.
7:12. Now I could see an accuracy. I could also see consistency. Am I right?
Yes.
Yes.
There is no bias and there is no inconsistency also. Suppose if one person says 7:12, another person says it is only 7 o'clock. Now, one
There is
person is
bias.
accurate, another person is inaccurate, and together, even if I take the average, due to the inconsistency, I will still have a bias. Can you see that?
Yes, sir.
Yes.
So, in order to make your readings accurate, you need to take care of two things. First thing to take care, tell me what will you do first? Will you make both the person give you the same reading? Or do you want to straight away work with one of the person? First of all, both
For
of
the
them
1%.
same reading. You must teach them how to measure so that their readings can be equal. And then if there is any problem with the instrument, and that can be corrected. So suppose imagine if the time is 7:12, and if my watch, sorry, 7, let's say my time is 7:15, but my watch is showing me 7:25. Now there is only one person taking the reading. Now there is only one person taking the reading and only one reading. So I am eliminating the issue of inconsistency. No issue of inconsistency because there is only one reading and then there is only one person. Now instead of 7:15, I am telling you that the time is 7:25. What do you understand now? Is my reading accurate?
No.
No.
Penalty.
So then you need to mute a lot of noise coming from your side. So the reading is inaccurate. How much inaccurate? 10 minutes faster. This is known as positive bias. This is known as positive bias, right? And suppose if my watch is slow, let's say 7:15, but it is showing me only 7:05. Now this time it is -10. This is known as negative bias. Do you understand? Positive bias, negative bias. As long as the bias is constant, we can still manage to get the correct time. As long as the bias is constant, the watch is still usable. Am I right? Sometimes you might have used, isn't it? Remember your old days, analog watches, right?
Yes.
It was 10 minutes faster, but we still used to wear it because we know how to manage it. If it is 10 minutes faster, what do? Every time we look at the reading, we subtract 10 minutes and then understand the true value or understand the correct value. This is called data calibration. This is called data calibration. After collecting the data, we adjust the data. In order to adjust the data, you should know the quantum of bias. All of you are with me?
Yes, sir.
Yes, sir.
Suppose if the bias is not constant, say the watch behaves very dynamically. You can't predict how much bias. You understand? The watch is behaving very dynamically. Now, it is difficult job for you to calibrate your data. Am I correct?
Yes, sir.
That's the time we will run to the nearby service center. Isn't it? Because we can't manage to find out the true time. So we run to the nearest service center and get our watch serviced. What that fellow might do, he might change the battery or he might change some small components that he has to fix certain things. As a result, our watch will now start working accurately. This is called equipment calibration.
Mhm.
If the data calibration is possible, yes, we have a way to get the accurate reading. If data calibration is difficult, then what do? We calibrate the measuring instrument. After calibration, we now realize our watch requires a service once in 3 months. Our watch requires a service once in 3 months. So we'll have the practice of replacing the battery once in 3 months. This is called calibration frequency. This is called calibration frequency. So if you calibrate your measurement system at appropriate frequency, right, and then take best care of the measurement system during its usage, no, then what happens? It can give you accurate readings. Ultimately, we want the bias to be 0. Our goal is the bias has to be 0, right? And if the bias is constant, we use a term called as stable. Bias is considered stable because it is constant over time. Good. But please note, to talk about the bias, consistency is the foundation. All of you agree with me? If there is no consistency, how do I calculate bias? Am I right? So consistency is the primary requirement before talking about accuracy. So consistency means if I myself measure characteristics multiple times, all my readings should be same. If I myself measure a characteristics multiple times, all my readings must be same. But in reality, in real time, there will be some variation. All of you agree? Will it happen?
Yes, person to
If
person
you
varies.
Yes, sir.
measure the same thing multiple times, then if there is a variation, that is known as repeatability error. I am not able to repeat my own reading. But if there are multiple appraiser involved, measuring the same thing, let's say you and me are measuring together, but my reading is different and your reading is different. Now, this is another form of inconsistency. This time we will call it as reproducibility error.
Hmm.
Agreed?
Correct, sir.
Right? So we need to have good control over the repeatability error, good control over the reproducibility error, so that whatever bias we calculate are really realistic. Am I right? Before calculating the bias, you need to ensure your readings are consistent first. Otherwise, even if you calculate the bias, it may not give real picture, right? So this has to be understood. And for managing the bias, there are procedures. After ensuring consistency, you can manage the bias. How to manage the bias? First approach is data calibration. And permanent approach is
Equipment calibration.
measuring instrument calibration. Over and above, you must have an understanding on the calibration frequency. Over and above, you need to know how to take best care of the measuring instrument. You should train your people on how to handle the measuring instrument during usage, during non-usage time. As a result, the bias can be minimal, throughout your project period, which is very, very critical for the success of the project. Which is very, very critical for the success of the project. So this is what you learned. Now your measurement system is good to go. Now you can collect the data and then calculate the baseline. And calculating baseline in terms of DPMO, we already mastered. Now what we are going to talk about is we are going to talk about yield. You know what is yield? Yield is output divided by input. And I also want to know, all of you, have you got the full proper clarity on the repeatability and reproducibility, or do you want me to do a small exercise here?
A small exercise.
Small exercise. Then we need to have a measuring instrument, and we need to have all of you becoming very active straight away, right? So let us take your stopwatch in the mobile phone. all of you take a stopwatch in the mobile phone. You all should be having mobile phone, 2, 3 mobile phone, right? Just pick up one and open the stopwatch. Just open the stopwatch and you can show it on the screen. Let me show you a stopwatch. I have. You all can see. Can you see my stopwatch? Very good. So I could see Vishwanath's stopwatch. And yes, all others, unless you show me, I can't understand what are you doing. Very good. So some people are really interested. Good. And now, thank you so much. Thank you. Now, so many people, Jyotika and Tushar. And now we are going to continue discussing, right? You can stay on the video. So now for any measuring instrument to give you very accurate, reading, the resolution of the measuring instrument is very, very critical. Better the resolution, more accurate will be your reading. Right? Now, what is resolution? The least count. Hope all of you know the meaning of least count, right? Least count is nothing but the lowest
Yes,
reading
sir.
that your measuring instrument can give.
Yes.
All right. Sometimes it is 1 millimeter, sometimes it is 0.01 millimeter, and so on with respect to vernier caliper or whatever. But now with respect to the stopwatch, tell me what is the lowest reading your stopwatch can give. Just check up the device and let me know. That is going to be the resolution.
1 minute.
1 minute. So any reading less than a minute, your stopwatch cannot give. Is it so?
Milliseconds, I believe.
1 second.
1
No,
millisecond.
1 millisecond.
1 second.
No, less than 1 second also possible. You need to check carefully. Less than 1 second also possible. Some people
Yes,
were
of course.
telling
Yes, sir.
milliseconds, but the unit is not correct. Your idea is correct, but the unit is not correct. That is not millisecond.
Microsecond.
That is not microsecond. Right? Milli means 10 to the power of -3.
Nanosecond.
Micro means 10 to the power of -6. Nano means 10 to the power of -9. What you have is 10 to the power of -2. You only have 2 decimals, isn't it? 1 second divided into 100 pieces. That is 0.01 second. It is safe to say 0.01 second if you are not sure about milli, micro, centi, etc. Let us straight away say 0.01 second. Got it? 0.01 second is the resolution or the least count.
Sir, what will be the unit?
1
What will the unit, sir?
unit. Okay. If you want to learn the unit, tell me 1 meter. When I divide into 100 pieces, what is each piece called as? 1 meter is divided into 100 parts. Then each part is
Centimeter.
Centimeter.
centimeter, right?
Yes, sir.
Centimeter.
So same thing is applicable to your seconds also. 1 second divided into 100 pieces.
Semisecond.
Centisecond. That is the correct answer.
Centisecond.
That's the correct answer. You can either call it 1 centisecond or safely 0.01 second.
Okay, sir.
And always when you are measuring, you are supposed to use only a common unit. If I am measuring in centiseconds, all of you should measure in centiseconds. If I am measuring in seconds, all of us must measure in seconds. We have to choose the appropriate unit of measurement and then proceed. Let us choose only seconds. That means 1 minute means 60 seconds. 1 minute means 60 seconds. All right. So now
Correct.
what we are going to do is, let us do a small exercise. And always what we use is, we use the tool known as gauge R&R. What is the purpose of gauge R&R? To check the accuracy or to check the consistency?
Consistency.
Consistency. Very good. By conducting the gauge R&R study, you check the consistency. And how much deviation is permissible? 10%. Once you are sure, yes, the inconsistency is lesser than 10%. Now you can start believing in your data. even then, even though you minimized the gauge R&R to less than 10%, still there can be inaccuracy. Am I correct? Even though you are consistent, you can still give me a wrong reading. If you consistently give me a wrong reading, do you think your readings are accurate?
No.
No. So after achieving consistency, you must try to achieve accuracy also. Then again, one more level of bias will appear. So the bias due to inconsistency, the bias due to inaccuracy, that is the total bias. This total bias must be lesser than 10%. Don't worry, we will talk to you on the same subject in a deeper manner, and you will be able to estimate the error. And the overall error must be lesser than 10%. And now you are sure about your data. Your data is now considered clean. Your data is considered credible, but the risk involved with your data is 10%. That is the idea, right? So with that note, let me take you to the baseline performance, right? Measuring the baseline performance. And what we are going to talk about is, we're going to talk about the yield. So any of you, do you know the meaning of yield? You might have used the word several times. Yield means output divided by input.
Input.
Output divided by input.
Input.
Just a second, I'm just getting. We'll quickly finish up this and then move to analyze. Yes, I got it. See, please note this kind of care is very, very important if you are working on a complex scenario where even the small difference matters a lot. Say, imagine you are paying for the gold you are buying. You can't, simply accept an error of, even 0.5 gram. You don't want to, right? The accuracy is very important. All right. So why MSA is important? MSA is important because we want to correctly understand the problem. Like we always, while driving the car, we want to see the road clearly. Same manner in Six Sigma project, you must see the problem clearly. How do you see the problem? Through the data only. How you clean your windshield? No, very often. Same manner, you must clean your measurement system so that you get high quality data and then you can understand the problem better. See here, there are 10 readings. We have averaged out. Even after averaging out, it is not matching the true value. The difference is known as bias. The difference is known as the bias.
Right.
And in this case, this is positive bias. In this case, it is positive bias. All right. So this is repeatability error and this is reproducibility error. And now we combine the repeatability error and reproducibility error. Together, it is known as precision error. This precision error is compared against the tolerance or your working range, which is nothing but USL minus LSL. This ratio in terms of percentage is known as gauge R&R. And how much gauge R&R is allowed? Lesser than 10% is normally allowed. Right? The industry practice is according to AIAG, the Automotive Industry Action Group, if the gauge R&R is lesser than 10%, the measurement system is considered good and acceptable. 10 to 30% conditionally acceptable, but more than 30% unacceptable. This is about the measurement system analysis. Now we are good with the measurement system. We collect the data and proceed to calculating the baseline performance, DBMO and then yield. Very, very simple. One is yield. There are three types of yield: traditional yield, first pass yield, and rolled throughput yield. Traditional yield, first pass yield, and rolled throughput yield. And the other one is DPMO, defects per million opportunities. Earlier we had GEMS exercise. Now we will have something else and calculate. And then CP and CPK. CP and CPK are known as process capability indices. We'll use it little later. See, out of these three, CPCPK tool is meant for continuous data. DPMO is meant for discrete data. Even the yield is meant for discrete data. Now tell me, what is continuous data and what is discrete data? What is the difference? What is continuous data or what is discrete data? Have you
Now,
discussed this?
Which data? Data
Sir.
which can be measured, it is the continuous,
Very good.
and which can
Discrete is
be
having
counted.
unit.
Counted.
Number.
Very good. Measurable characteristics
Number.
are continuous data. Countable
And counted.
characteristics are discrete data.
Discrete data.
In other words, if an unit of measurement is available, then your data is continuous. Like centimeter, millimeter, seconds, kilogram, milligram, all of these things. Whenever you see a unit of measurement along with your data, that means your data is continuous. If unit is not available, then it is discrete. All right, you have a good clarity. And now traditional yield. Very, very simple. Imagine you have got Google Pay or Phone Pay or something, using which you make 100 transactions. Out of 100 transactions, 10 transactions failed. So 90 transactions, you are able to make the payment properly. So 90 transactions are successful. Now, what is your success rate now?
90%.
90%.
90%.
90%. That is known as traditional yield. That is known as traditional yield. Here, we only measured our success and compared against the maximum. Our success is 90 and the maximum is 100. So 90 by 100 is 90%. Very, very simple. Output divided by input. Now, let me give you another scenario where 100 transactions are happening. Out of 100 transactions, 30 transactions, there was a delay. 30 transactions, there was a delay. You might have experienced, isn't it? You are paying to a vendor, but then, it is showing under process. Now the fellow will not allow you to leave the shop. You have to be there till it becomes, successful. So there is a delay.
Correct.
But after some point of time, out of the 30, 10 of the transaction failed. Even after delay, 10 transaction got failed. Now totally, how many transactions are successful? 90. All of you understand the process now? Now I want you to calculate what is your yield now. Is your yield 90% or is your yield 60%? Tell me. Do you get my point, all of you?
Yes.
Sir, as per formula, it will be 90%.
Yeah. If you only look at the output and input, you are 90%. Traditional way, most of the time we calculate in this manner only. Rarely we look at what happens in between, isn't it? But in between what happened, a delay happened. That means some failure has happened. Can you see that, all of you? Some failure has happened. Some people have reworked on it and somehow the failure is converted into a success. Somehow the failure is converted into a success. This is called rework. Am I right?
Yes.
So the rework percentage should be subtracted from your success. All of you agree with me?
Yes, sir.
How many of you are
Yes, yes,
interested in
right
clearing
first
the
time.
exam by writing it 2 times? None of us, right?
Nobody.
We all want to pass in the first attempt. Similarly, we all have to produce right at the first attempt itself. If you are concerned about doing things right at the first time, you must choose to use first pass yield and not the traditional yield. You must use the first pass yield and not the traditional yield. And so we make a minor change in the formula. Now we subtract the rework quantum from the output. Even though we got 90 units successful, the reworked units are subtracted now. Reworked units are subtracted. And so the actual first time right transaction is only 60%. It is only because of the reworked quantity getting added it has become 90%. Otherwise, it is only 60%. So what we thought as 90% is not 90%. It is only 60%. All of you understand?
Yes.
Yes.
It is like 100 people writing the exam and 90 people passing. We immediately tend to conclude that our success rate is 90%. But after analyzing the details little deeper, we realize 30 students, they passed the exam in the second attempt. That means the program is effective to only help 60 of the students pass the exam in the first attempt. 30 people have done the rework, right? Rework is a failure. We must recognize that. So first pass yield is always, lower than the traditional yield, lower than or equal to the traditional yield. So which is a better measure now? Traditional yield or the first pass yield?
First pass yield.
First pass yield.
First pass.
Hereafter, please look for the first pass yield. You will realize enormous opportunity for improvement. Otherwise, you will immediately settle, oh, I'm already 95%. Okay, I'm doing great. But if you calculate the first pass yield, you realize you are not 90% or 95%. You are only at 60%. Now there is a lot of opportunity for improvement exist, right? That's the idea. Now another tool is rolled throughput yield. So rolled throughput yield, you can use. Sometimes people call it throughput yield. You can use if your processes are linked and then happening in sequence. Other words, the output of the process becomes input for the next process. If your processes are connected in this manner, now rolled throughput yield can be calculated in two methods. One is the final output divided by initial input. One is final output divided by initial input, or otherwise you can calculate the first pass yield at every stage, because we always have different managers or different process owners. See here, the first process, how much is the first pass yield? 90%.
90%.
Now second process, how much is the first pass yield? 80%.
50%.
Then there is a third stage where there is another process owner, the yield is 70%. I mean, first pass yield is 70%. So individually looking at the yield, it looks somewhat better, except the third stage, isn't it? First stage 90%, second stage 80%, third stage 70%. Now, what do you think will be the overall yield? Any idea? What will be the overall yield now?
50%.
How much?
50%.
50%. You're very true. Very, very true. Now, how this 50% comes? We just multiply the first pass yield of every stage. 0.9 multiplied by 0.8 multiplied by 0.7. Let's understand this with a simple example. Imagine you produced 100 parts. How many parts you produced? 100 parts. What is your success rate? 90%. So how many units are now acceptable?
90.
90. 10 units are rejected. Now the 90 becomes input for the second stage. Now what is the success rate at second stage?
80.
80. Now tell me, what is 80% of 90?
72.
72. Now 72 units are acceptable. That becomes the input. Now the third stage, the success rate is only 70%. What is 70% of 72?
49.
50.4.
49 or 50. That is what is appearing here. And mathematical way is simply multiply the yield. 0.9 multiplied by 0.8 multiplied by 0.7. All of you, do you understand?
Yes.
Got it, sir.
Imagine you are the manager. 3 people are working under you. And the processes are going in sequence. Now, the first person reporting to you, he maintains 90%. He maintains 80%. He maintains 70%. But the super boss in your company, he is questioning you. Now, what is your yield? Your yield is only 50%. Can you see that, all of you? You are in deep trouble now. If you want to have a respectable number, then you need to find out the bottleneck. Here the bottleneck is P3. P3 must immediately be improved, because if the P3 is 70%, your result should definitely be less than 70%. And that will be pulled down by the other process also. That's why you have gone around 50%. Now, you know now, for your position will be very difficult, because 50% means, no, it is like head or tail. Your presence is not at all required. Can you see that here? Head or tail, 50% chance, right? So always yield means it should be, at a respectable level, right? So do you understand when to use the roll to throughput yield?
Yes, sir.
Yes.
All right. Many processes. Like in a bank, you apply for a loan, then first stage, it is scrutinized for the verification of the document. After that, it is scrutinized for your, loan eligibility. They do some credit check and something. And then the third stage, it goes to the bank manager's recommendation. And then finally, fourth stage, the bank will announce whether your application is accepted for the loan or not. So again, there you can use the throughput yield. Hope it was clear, all of you understand. Yield, traditional yield, first pass yield, and the last one,
Roll
rolled
throughput.
throughput yield. All right. And DPMO, we already calculated for GEMS experiment. Now another scenario. Imagine you all have to fill up a Google form where there are 10 questions. Now how many questions you can answer wrongly? Maximum?
10.
10.
All 10 we can answer wrong, right? Very easy job for us. So all 10 we can answer wrong. That means the opportunities for defect is 10. You can give your name wrong, you can give your date of birth wrong, everything, all can be wrong. That means the defect opportunity is 10. Can you see here? Now 15 people are filling the form. Now what will be the total opportunity for defect? 15 into 10? 150. You can see that. Now all the 15 people filled up the application. Now you are checking the report. How many are correct? How many are wrong? You are able to notice 22 entries were wrong. Now what is the DPMO here? Do you think you will be able to calculate? All of you do the exercise yourself. You have the number of total opportunities, 150, and defects observed, 22.
22.
Now you have to calculate defect per opportunity, and you have to multiply the defect per opportunity by 10 power 6 so that you get DPMO.
Yeah.
Is it an easy situation to handle?
No.
Right? No. No means you have to do it now. You practice.
No, sir. Practice. This situation is difficult.
Yeah. So, see, always,
That-
if you want to understand the DPMO,
From 10 defect,
understand.
from number of defect 10, that DPMO goes to 1,46,000.
Exactly. Yeah. Situation. Yeah. 1,46,000 is too big number.
Yes.
When we aim for Six Sigma performance, the target DPMO is 3.4. And now 1,46,000, clearly explains an out of control situation. Situation is completely abnormal. Definitely action is required. And now to convert the DPMO into sigma level, I gave you a method, isn't it? Sigma level calculator I have shared.
Yes, sir.
You can type there and that will give the sigma level. All right. So hope it is clear to all of you. Now there are two methods of baseline we have understood. One is yield, another one is DPM.
DPM.
And DPMO can be converted into sigma level. That is third method. Sigma level, our goal is 6. Right? Something like that. And CPC began few other things. We'll see it little later. So any question on the measure phase? I'm open to it. So capability of a process can be measured in terms of traditional yield, first pass yield, throughput yield. First pass yield is the probability that a process can produce a good output without making any defects and without doing any rework. Now underline, rework is a failure. Rework is a failure. DPMO stands for defects per million opportunities. This metric can be used for measuring the capability where output is measured in discrete units. DPMO is to monitor and control the defects, whereas PPM, what does PPM stand for?
Parts per
Parts
million.
per million.
Parts per million. Parts per million is to monitor and control defectives. Even if a company has achieved a PPM of 0 PPM, still DPMO can be 40,000. Do you understand? Even if a company achieve a 0 ppm, it doesn't mean that everything is perfect. Still, there can be defects happening. That's the advantage of working with DPM. Hope all of you understand what I'm speaking. And DPMO of lesser than 3.4 indicates the process capability is 6 sigma and above. This is what you need to understand in measure phase. Any questions?
Okay.
Now we are good to
No, sir.
analyze.
Sir, any real exam is there? Actual 0 ppm to defect means.
No, real, see, real example means companies, they keep a big board, 0 ppm on the outside. That is the real example. But
Okay.
what is the actual rejection? We need to verify the data. We need to verify the data. There will be ppm.
Data integrity issue. There is data integrity issue.
Yeah. So let us say the company has a ppm of, let's say 300. What does it mean? ppm of 300 means
300 part effective
300
of 1
parts
million.
they
out of 1
produced 1
million,
million parts.
and 300 parts are defective,
300 parts are rejected.
rejected.
Yes, sir.
Now I want you to check each and every part, 100% investigation. I want you to do with the 300 rejected parts.
Okay.
Now first 100 parts are rejected because there was a defect in each piece. First 100 parts, one defect is noticed in each piece. All right.
Yes.
Second 100 parts you are checking. You are noticing 2 defects in each piece.
Okay.
Third 100 parts you are checking. You are able to see 3 defects in each part. Now totally how many defects you noticed?
600,
600. But how many pieces you inspected?
300.
300.
Percentage
300.
defect and defectives.
Yes. Now your numbers are 600 defects observed against
300 parts.
how many pieces?
300 pieces. Or 1 million.
1
1 million.
million
1
pieces.
million.
1 million
DPMO.
pieces
Correct.
produced.
Produced.
But how many defects you observed? 600.
600 defects.
I want all of you to note this number in your piece of paper. Please write down now. 600 defects and 1 million units. 600 defects and 1 million units. Now, let us also understand the maximum number of defects possible is 3 only. That is what we observed in the last 100 pieces. Maximum number of defects possible is 3. Now, when you have produced 1 million parts, what will be the total opportunities? 1 million parts into 3
Three.
defects each. That is the
3
maximum.
million.
3 million. 3 million.
So
Correct.
write down. Total opportunity is 3 million. Total opportunity is 3 million. Now you have 2 different number. One is number of defects equal to 600. Total opportunity equal to 3 million. Now I want you to calculate defects per million opportunity. Now tell me, how will you calculate? Little mathematical, tricky situation. 600 out of 3 million.
3 million.
But I
Hmm.
want to find out the defects out of
1
out of
million.
1
1
million. 1 million.
Now what is your DPMO now? Intelligent people can straight away give the answer without even calculating. I know all of you are intelligent. You all will give.
600.
3 million
600.
opportunities. You have seen 600 defects. That means
100.
out of 1 million opportunity, you have seen
200.
200.
200.
200.
So 200 is the DPMO.
Correct. Hmm.
All right. But ppm is
0. What they are
Okay.
mentioned.
So that is the advantage of working with DPMO. But only after controlling the PPM, you will be able to think in this manner. If PPM itself is very big, 5,000, 6,000, then they may not be interested in talking in terms of DPMO. Hope all of you agree with me.
Correct.
When we have a bigger problem, nobody will be interested in smaller problem. It won't get prioritized. But if the bigger problems vanish, smaller problems will gain importance. Got it? That is what is happening here.
Yes, sir.
Okay, any other question anybody would like to ask?
No, sir. Thank you.
Perfect. So now we are getting into the important module of Six Sigma. What is the important module?
Analyzation of
Analyze.
data.
What is your goal now or objective now? You defined the problem. You measured the problem. You have a crystal clear clarity of what is exactly happening in your shop floor. You have crystal clear clarity of what is exactly happening in your shop floor. Now you have to okay. So you have to find out the root cause for the gap in performance. Please tell me, in the define phase, you have set the target. Am I right?
Yes, sir.
For DPMO, you have set the target. For rejection rate, you have set the target. For yield, you have set the target. There are different ways you can set the target, right? But the baseline is much below the target. Now the difference is the gap in performance. And what is the reason for the gap in performance? We need to figure out the root cause. We need to figure out the root cause. So when you are on a journey to find out the root cause, you should be able to understand the difference between the symptoms and their causes. Right? Most of the time what we do is we are tempted to take action on the symptoms. In return, we continue living with the problem. So we should always talk in terms of the causes. All right. So now for that purpose only, we have the analyze phase. Let me take you through the slides. So you all can see my slides now. Analyze phase, toll gate review. See, toll gate review happens at the end of the analyze phase. If you say you are done with the analyze phase, then only the review will happen. And the questions we are going to understand. And the steps involved in the analyze phase. The tools that can be used in the analyze phase. And finally, the deliverable. The deliverable is validated root cause. Validated root causes. So first question. Have you identified the source of waste, risk, or variation? Of course, Six Sigma means the problem is variation. So what is the root of the variation? In lean, the problem is waste. So what is the root of the waste? Similarly, in risk mitigation, what is the root of the risk? Have you identified the potential and the critical causes? There is a difference between potential cause and critical cause. We are going to talk about it. Potential cause means we have a strong suspect that the factor is the root cause. When I say critical, that means you are underlining, yes, this is the root cause. Critical cause means root cause. Potential cause means potential root cause. Then, have you statistically validated the root cause? Suppose if you figure out a certain factor as the root cause, and if people around you are not agreeing to it, now you have to statistically prove, statistically validate. Statistically validate means you have to prove experimentally. Statistically validate means you need to prove experimentally. I am telling you that if I add less sugar, my coffee will become less sweeter. All of you agree with me? Now I don't have
Yes,
to prove further because you all have agreed to me. You all have agreed to me, so now I don't have to prove anything further. If I add less amount of alumina content in the molten metal, then my castings will have poor surface finish. Now, how many of you agree with my statement? Now it's a doubtful scenario.
I am not agreeing.
I may be an expert, I may be telling something, but you don't have to believe everything I'm telling, isn't it?
Yes, sir.
Now comes the necessity to verify the statement given by the expert experimentally. Right? Once the statement gets validated, you can believe in the expert statement. If it doesn't get validated, you can understand that opinion is not applicable in your process. All of you, please note, the root cause can be different for the same problem in two different scenarios. Am I correct? The root cause can be different for the same problem in two different scenarios. Two person having same pain in the abdomen, but the root cause can be different. Am I correct?
Yes, sir.
Two patients have the same problem, but root causes are different. And so the treatments have to be different, right? We need to understand. Has the validated factors sufficient? That means now the question is how many root causes are actually involved? Or how many factors are involved in the problem? Or how many culprits are involved in the crime? This is the question. You need to figure out answer for all of this. So why we are talking so deeper? Because the problem is really critical. We want to solve it. At the same time, the situation is very complex. We have to conduct a lot of experiments to understand. Now, finally, have you identified any new risk? I mean, the risk levels should also be able to understand. We need to understand the risk level. Is there any new risk you identified in your analysis? These are all the common questions. There can be additional questions. You may also know certain questions. Now, we proceed with understanding the steps involved in the analyze phase. First thing, list possible or probable X factors. Why do I bring X here? Because for the problem, we use the symbol Y, isn't it? Y is the output variable. Why there is a problem with the output? Because there is too much variation in the input, right? That X we want to identify. So first step, list possible or probable X. Then identify the potential factor and then validate the critical ones out of the potential ones. You need to figure out the critical ones from all the potential causes. After that, you need to verify the sufficiency. How many of you understand the meaning of each and every step? All of you? It's simple language only, right? Possible factors, also known as probable factor. After that, potential factor. After that, critical factor. And finally, you need to understand the sufficiency. If you could if you can do all of this, you're good with analyze phase. Let me help you understand. Let me help you understand this. Imagine there is a big party happening. There's a wedding function happening in a hall, in a party hall. And during the function, let's say the jewelry kept in a room worth 100 sovereigns is missing. Now, what will you do? What we do immediately? We call to the
Police.
nearest police station. What is that they will do first?
Investigate
Now,
everyone.
yes?
They will
Investigate
Containment.
Analyze possible factors.
Containment and means
सारे लोगों को
area
very good.
ये कर
Confinement. They will
Hmm.
secure the place.
secure the place.
They will advise, to close the door. Don't allow
Yes.
anyone to move out.
No,
Don't
correct.
allow any new person to come in. Because their suspect is definitely the person
Inside.
who took that jewelry should be inside the hall only. Right? Suppose if it is happened just now, then definitely he should be inside. Now, imagine if there are 100 people in the hall. Definitely the culprit is within that 100. All right?
Yes, sir.
Culprit is within the 100. That means all the 100 people together is known as possible X factor. Am I right? But,
Correct.
but never police arrest all the 100 and take them to, police station. You know why? They don't want to work in an inefficient manner, isn't it? Rather, they will do some little investigation in the party hall itself. They might speak to people. They might refer to the CCTV camera. They will find out that they will, analyze where the jewelry was originally kept. With these kind of, available information, definitely they will be able to segregate people into two groups. Am I right?
Yes, sir.
One group of people where the suspect is very high, another group of people where the suspect is very low. Let's say there are about 10 people on whom the suspect is very high. They are now known as potentially critical factor.
Critical factor.
They are now known as potentially critical.
Potentially critical.
It doesn't mean that all the 10 took the jewelry. No, we don't know. We are not sure. But definitely that fellow is inside the 10 now. That is our assumption. All of you understand the meaning now? Potentially critical. Now these 10 people will be taken to the police station. The investigation at the next level will happen at the police station. Am I correct?
Yes.
Yes or no?
Yes, sir.
Yes. Now, out of the 10, they may figure out there are 3 out of the 10 are involved in this crime. 3 out of the 10 are involved in the crime. That means how many root causes? 3 root causes. Now we need to understand who is the leader of the gang, isn't it? Out of the 3, who is the leader? Which is the major contributing factor? Let's say one person acted as the group leader. He might have taken half of the stolen item. Out of the 100 sovereigns, he might have taken 50. Remaining 2, 25 each. Now we understood the contribution of each of the factor. When I add the contribution, it is tallying to how much? 100%. Isn't it? We lost 100 sovereigns and we recovered 50 from one person, 25 from another person, and another 25 from another person. Now, how many root causes? 3 root causes. And when we sum up the contribution, it is coming to 100%.
Right.
That means the root causes identified are sufficient enough to solve the problem. This is called factor sufficiency. In order to understand the factor sufficiency, you must calculate the percentage contribution of the factor with respect to the problem you are solving. Do you understand?
Yes, sir.
There is a beautiful tool which can talk about the percentage contribution. You know what is the tool? R square. The tool name is R square, which is known as coefficient of determination, right? And you need to learn about R and then you need to learn about R square, right? All that will happen in the analyze space. Now moving on. What is the final output? Final deliverable? Validated root causes. Sometimes root cause is 1, sometimes root cause is 2, sometimes root cause is many also. And you need to understand the sufficiency with the help of R square. If R square is more than 80%, now you are sure that your actions can solve at least 80% of the problem. If R square is 80%, you are sure that your actions can solve at least 80% of the issue. If R square is close to 100%, that means you are giving your company a perfect solution. How are we talking all of this? With the help of our experimental readings. With the help of our experimental readings. Once you have experimental readings, that is data, you are using statistical tools. You can use statistical tools and you can start predicting. You can start predicting, right? And based on your prediction, R square is this much, and so my actions should solve the problem. Even before implementing the solution, you are judging on whether the solution can really solve the problem or not. Now the tools, some mapping is given here. Possible X factor. In order to figure out the possible X factor, you can use tools such as brainstorming, YY analysis, and cause and effect analysis. You might have used all these tools. Am I right? Brainstorming is a meeting with the coffee, snacks, and everything. That is brainstorming, right? And it can be structured or unstructured, depending on the requirement. And along with the brainstorming, you can also use YY analysis. You can also use cause and effect analysis or cause and effect diagram. And for potential, identifying the potential factor and then validating the potential factor, we need to learn all of this. And again, this is going to be a next level of stuff. I'm not going to bother you with all this content right away here. You see here, null hypothesis, alternate hypothesis, type 1 error, type 2 error, probability of significance, test of mean, test of proportion, all that you will be learning. This is pure statistical tool. Yes, that will make all the difference, right? You will be able to stand out. And now finally, to verify the sufficiency of the factor, the tools you need to learn are correlation analysis and regression analysis. All right. And now the bigger picture of analyzed space. The objective is to identify and validate the root causes. We need to list all possible or probable X factor using tools such as brainstorming, fishbone diagram, YY analysis. We can narrow down the focus using Pareto analysis. There is another equivalent tool known as cause and effect matrix or impact control matrix, right? Similar to Pareto, it will work. Ultimately, like how the police people segregated 10 out of the 100, you need to segregate the potential ones from the trivial ones. And once the potential ones are segregated, you need to formulate hypothesis and validate the root causes. And the procedure is known as hypothesis testing. Hypothesis testing is a statistical procedure by which the root cause can be validated experimentally. Always please use this tool, hypothesis testing, only if there is a need. If everybody is ready to accept you, you don't have to conduct any experiment. All right? If people are not in a position to accept your recommendation or accept your finding about the root cause, that's the time you must use hypothesis testing. Hope all of you understand the suggestion here.
Yes, sir.
Just because you know something, don't try to use everything. Right?
Sir.
Not required. Only if a need arises, if people are asking questions, hey, how do you say this is root cause? Now you have the responsibility to prove it. Now, then you go for the hypothesis testing. Verify the sufficiency with the help of the regression analysis, and the specific name of the tool is R square, which is also known as coefficient of determination. Now you got the bigger picture of analyzed space.
Okay.
All right. Yeah. Any questions so far? Any question? All of you are clear now? Tell
Yes,
me
sir.
what are the 3 steps in analyze phase? Step number 7, 8, and 9. What are the 3 steps?
List of possible
Try to
List
list
of
down the possible probable
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 cause,
X factor.
causes,
Very good.
Identify and
then validate
validate
critical
Identify and
factors,
validate
critical factor.
factors.
then
Ah,
verify sufficiency of
Verify
critical
sufficiency
factors.
of
critical
very
factors.
good. List out the possible factor. Then separate the potential ones and validate them. If it gets validated, it becomes the critical factor. That is the root cause. After that, you verify the sufficiency. Verify the sufficiency means you are asking the question, how many root causes? If there are multiple root causes, what is the contribution of each? And the total should be close to 100%. If it is not 100%, it should be at least 80%. If it is not even 80%, then you know what will happen. You might take action, but still the problem will keep continuing. Isn't it? It is like, a pot with some multiple holes. You fix only one of the hole, but still the water keeps leaking. So something like that, right? So that we are checking. So now, in order now to understand the first step, listing possible factor, we can think of using this tool brainstorming, YY analysis, and cause and effect analysis, and then finally impact control matrix. The impact control matrix will help in separating the potential ones from the possible factors, separating the 10 from the 100. Now, what is brainstorming? Instead of reading the theory, let us do a live exercise. So, in order to do a live exercise, we need to take a problem which all of us can easily understand. Can you suggest me a problem which all of us can easily understand? Yes. What is the problem we can solve? Can the topic be obesity?
Okay, sir.
Yes.
Okay.
All of us know obesity, right? Overweight. More than the ideal weight. Now, we need to figure out the root cause. But our goal is not to talk on the root cause, but to talk on possible causes. How can one become obese? I want each one of you to type one option in the chat box. I want each one of you to type one option in the chat box. Let all of us look at the chat box and let's understand. Now, Munira says sedentary lifestyle, eating more, fat content, unhealthy diet, excessive junk eating, overeating. Okay. Excess carbohydrate, fast food, health issues. Okay. Not doing exercise. Again, junk food, less activity. What do you understand now? Less walking. What do you understand? All of these things are okay. Okay. So all of these things are X factors. They are called possible X factor. Can you see here? Now the step number 7 is over. But now please note, we need to have proper members participating in the brainstorming session. Isn't it? People who are really concerned about solving the problem. They have to be invited. Stakeholder analysis, right? So all of these, that's how now in just, very short span of time, can you see number of X factor in the chat box? Number of X factor. That is the beauty of brainstorming. But it has certain limitations, certain advantages, certain disadvantages. The advantage is in less time, you get so many factors. But what is the disadvantage? What is the disadvantage? Some people, can you see some people not at all responded?
Person specific may be also there.
Yeah. Some people, might share their own views. It may or may not be a cause. So you need to know the plus and minus of what you are doing, and then take decision accordingly. And brainstorming can be of two types. One is structured, another one is unstructured. I wanted each one of you to type only one cause, isn't it? Otherwise, you know what would have happened? One you could have typed several X factors, isn't it? That is also possible. So if there are some conditions added during the brainstorming, then it is known as structured brainstorming. If absolutely no conditions are added, then it is unstructured brainstorming. If I make it compulsory that every person should talk, what is this brainstorming? Structured, right? Structured. Otherwise, it is unstructured. If compulsorily all of you should come on the video, then the training is structured training. No condition, leave it to you. Then it is unstructured. Each has a plus and minus, isn't it? If everybody comes on the video, then data consumption will be more, isn't it? There are many plus as well as minus. Similarly, if nobody comes on the video, then again, there are a lot of plus and minus. We need to understand and then use accordingly. Now you can see brainstorming happening here, and that's what we also did. Now, the another tool is why analysis, also known as 5 why analysis. Why this is required? This is required because sometimes, the team, the participating team, they may not talk in terms of the causes. Rather, they might talk in terms of the symptoms. Isn't it? Symptoms are different from causes. So you need to do something to peel away the symptoms so that the causes will become visible. For that purpose, nothing wrong in asking the question, why? Say, for example, many people are not coming on video. Is it a cause or a symptom?
Symptoms.
Symptom. If they want to learn, definitely learn a lot from the program, then obviously they will understand their responsibility. So always, we need to understand whether the factor we are working on, is it really a cause or it is just a symptom, right? And only for the causes you need to take action. For symptoms, if you take an action, maybe it may be a temporary relief, but then the problem will still continue. So we will better understand this with another, classical example. And first of all, the tool is developed by Sakichi Toyoto. We all know him, right? So the Toyota production system. And he stated that by asking the question 5 times, why, the nature of the problem, as well as the causes and the solution sometimes becomes very clear. Let's see. And now, let me explain the problem. Now, you people are going to read out along with me because there is a lot of sentences here. I'm not going to read it alone. So the problem here is one of the monument in India is deteriorating. You know, deterioration means it is fading. It was looking very bright and shiny, but now it is not so. And so the team wanted to understand why it is happening so. So the first question is asked to the maintenance team. The team that is taking care of the maintenance of the monument. The first question, why is the monument deteriorating? Now, one of you can read out the answer on the right side.
Because harsh chemicals are frequently used to clean the monument.
Because harsh chemicals are used. So my next question would be, why are you using harsh chemicals?
To
Now
clean off the large number of bird dropping on the monument.
Okay. There are a large number of bird droppings which I can't clean with normal cloth or something. So I have to apply the chemical. That is your point. Now my next question is, why are there large number of bird droppings on the monument?
Because the large population of spiders in and around the monument are a food source of the local birds.
Oh, is it so? Large spiders on which the birds feed on. Now my next question is, why there is large population of spiders in the monument?
Because vast swarms of insects on which the spiders feed are drawn to the monument at
Okay.
dusk.
Okay. So there are large swarm of insects, that are there in the monument, particularly in the edges and somewhere. So now the next question: why are there large swarm of insects drawn to the monument?
Because the lighting of
Because the
monuments in the
lighting of the
evening
monument
attracts the local insects.
Oh, the lighting of the monument attracts the insects. And now look at the flow, look at the connection, and look at the last line. We are trying to find out why the monument is deteriorating. And finally, we can also see the chain of causes in here, isn't it? One is causing the other. Now, what is the original cause? Lighting. Whether the lighting is too bright, too much lighting. If you put too much lighting, you know what happens? Insects will get attracted, in a higher, larger manner. We might have noticed. Sometimes if everyone in the apartment, they switch off the light and you alone keep the light on, then automatically, all the insects will get attracted. And so the intensity of the lighting, the timing of the lighting, the location of the lighting requires an attention here. Am I right? The location of the lighting, maybe you can keep them little away from the monument. And maybe you can change the timing so that, everyone can lit the light. And so the insects can go scattered. Isn't it? And you can also think about whether really such a level intensity of light is required, or can we reduce on it? Look at the problem and look at the solution. Right? We never thought that lighting could have been the reason for the monument deteriorating. But this kind of analysis sometimes can change the perspective completely, and you will be able to take right actions. But again, always, even though you use a lot of tools, one important tool we must always use is our common sense. That's much more important, right? Even though Six Sigma or whatever we speak, final flavor is your common sense. If you fail to use the common sense, even the best of the science and engineering available can mislead you. You have to be very, very careful. All right. So why by analysis is something. And similarly, another scenario here, you can easily understand. The roads are dirty in a particular, industrial campus. Then what we normally tempted to conclude is, again, to blame the housekeeping department or the cleaning department. But if you investigate properly, you might, come to understand why the roads are dirty. Because there is an oil leakage. Why there is an oil leakage? Because there is a leaking oil tanker. Why the tankers oils are leaking? Because there is poor maintenance, of the tanker lorries used in the campus. And why poor maintenance? The drivers and the cleaners are untrained. So the permanent solution to the problem is training your drivers and cleaners on proper maintenance of the tanker lorries. Not simply appointing, too many cleaning staff. That's not going to solve the purpose, right? So that's the idea. So this is what is known as why analysis. You can use it. Hope it is clear to all of you. Am I right?
Yes, sir.
Yes, sir.
One is brainstorming, one is why analysis. Please note, our goal is now to list possible factors. Now the next thing is the fishbone diagram. You see here, the obesity, whatever we spoke, it is now expressed in the form of a visual. Because a picture can speak 100 times better than your statement. So that's why, we are visualizing. Now the problem is written on the head of the fish. Can you see that? What is the problem? Obesity. The causes are written on the bones. There is a main center bone, and then there are sub bones, and under the sub bones are known as the categories. Categories can be 4, 5, 6, depending on the requirement. Here in this particular fishbone diagram, how many categories are shown? 6 categories. What are they? 6M, men, machine, method, material, other nature, and so on. It need not be always 6M, please note. It depends on the kind of problem you are solving. But one generic method is 6M. Suppose I want to improve the training effectiveness. I want all my students to score above 90 in the first attempt itself. Now what should I do? Now my categories will be training material, the knowledge level of the trainers, right? The participation of the candidates, isn't it? And maybe the platform in which we conduct. So I choose certain certain categories which are relevant to my problem. All factors related to the trainer will appear under the trainer category. All factors that are relevant to the candidates, that will appear under, again, participant category. All factors related to the course material, that will appear under the material category or course material. And similarly, the examination, all of this, so we can have the relevant categories, and then we can have this exercise. Please note, while brainstorming, while conducting Viva analysis, while creating the fishbone diagram, never discourage the person who is sharing the idea or who is sharing the point. Don't discourage. Please note down. Because let's say if you discourage someone, then the hall will become completely silent. That's not the purpose, isn't it? So don't discourage anyone. Allow them to speak. You note down everything, and then later on, you apply your common sense. Or maybe a team of people can take the responsibility to remove the odd ones and have only the relevant ones in our fishbone diagram. Hope all of you understand how to draw the fishbone diagram. The idea is people can now have a clarity on the possible cost factors. Now, process knowledge again comes into picture. That is why we wanted you to think about the process in the defined phase itself. If needed, look at the process flow diagram also. If you look at the process flow diagram, then you might note down some more points. Now this is a fishbone diagram for another situation. What is the problem here?
Wrong, delayed, damaged delivery.
Delayed damage.
See here, in my fishbone diagram, there is a problem. There is a mistake. Can somebody figure out what is the mistake here?
Direction.
Direction. Can you elaborate? What do you mean by direction? What is the mistake here?
Writing.
Nothing wrong. Make it try. I'm not going to find fault. In Six Sigma, we always try to solve one problem at a time. One at a time. But look at your Y variable.
Multiple. Okay.
Multiple things are written. Now that means my problem is already complex and I am complicating further. Am I right?
Correct.
So we should avoid that. But if you really have the enough confidence to handle these multiple issues in one go, and if you feel that you can definitely solve, then I have no problem. But otherwise, the better approach is drawing 3 different fishbone diagram. Agree with me?
Yes, sir.
Why damaged delivery is happening? That is a separate fishbone diagram. Why damaged delivery is happening? Packaging material is wrong. Item handling is not proper. Transportation, there is a problem. On the roads, there are a lot of ups and downs. These are all the reasons for damaged items. Isn't it?
Yes, sir.
Yeah. So it is better always to draw fishbone diagram separately. Scoping the problem is very, very important at all stages. Right? And simply making the boundaries invisible cannot help. Always it is better to see the boundaries. Oh, this is the problem. Let us talk only about it, right? So that way, this fishbone diagram is not a great one, right? But now, this is a simple issue. Like the delivery has to teach the customer in proper shape and proper time. So that's why it is given in a single diagram. But knowing the limitation of it, we are still discussing it. And now that you understood all the factors here, all of them are commonly known as what?
Causes,
X.
X
Now,
factors.
I don't want to take action on all the X factors. I want to be efficient because there is a reason. Yes. People are looking at me on how am I, working. Many eyes are on me, isn't it? So I simply can't waste time and waste the resources available. So I have to be intelligent enough to take only the right actions and not the unnecessary actions. So what I do is I'm going to separate these factors into two categories. One, I'm going to call it as potential factors. The other, trivial factors. Trivial, currently not problematic. But the potential ones are the real problematic factor because my suspect is more. So in order to do that, I suggest you another simple tool. There are different ways. See, what we are trying to do is we are trying to prioritize. We are trying to prioritize. So now this tool is known as impact control matrix. You can see 4 quadrants. This quadrant, red color, is nothing but high impact, high control quadrant. Here it is high control, low impact. Here it is low impact, low control. Here it is high impact, low control. There are 4 quadrants. What you need to do is you need to critically analyze each of the factor and place them in one of the quadrant. What you need to do? You need to critically analyze each of the factor and place them in one of the quadrant. Let's do a small exercise here. Let's do it for one particular factor and same manner you can repeat. And finally, all of them that appear in the red color quadrant are the potentially critical factors because their impact is high and the controllability is also high. All of you understand? So let's do it. Now, first one, if your team is using a wrong packaging material, what will be the impact?
High control, high impact.
High impact.
High impact.
Please note, when we talk in general, we immediately conclude that it should come here in the red color quadrant. But let us go to the real scenario in your company. Poor packing materials are used, right? But are you using a wrong packing material for packing all the items?
No, sir.
No.
Next level of question, isn't it? There are many items you are packing properly, but very few items you are not using the right packing material. Maybe, the reason has to be figured out. And now what do you think the impact is? High or low?
Low.
So you need to understand the real scenario before placing your factor in any of the quadrant. We are only speaking hypothetically, isn't it? We just simply assume and then I speak in a way that you bring everything in the red color. Right? But real analysis should go as per the real conditions in your workplace. All of you understand?
Yes, sir.
Don't hesitate to ask questions. Questions can throw light, right? So now, wrong. Okay, let me come here. Mishandling of products. Mishandling of products, right? People are, collecting from the warehouse or, from bringing from the storage area, and then they have to pack it and then they have to give it to the dispatch section. Now, mishandling, that means, they just throw here and there and they just catch between, people. All of these things are happening. And if you notice, or if you suspect that all these things can happen, then how will you categorize? Will you categorize as a high impact problem or high impact factor?
Low
So
impact.
low control, high impact.
Okay. Why it is low control?
Because people are not doing it in a, it is a given that people are not doing in a not doing a proper channel. They are not following SOP.
Okay. If people are mishandling, that means, there is a problem,
Problem in
the mindset, isn't it? The well
Behavioral.
set, well written procedures are available, but still they don't follow. They are not
Behavioral
supposed to,
issue.
throw the items onto the table, or they are not supposed to, catch between them. So all of these things are strictly not allowed, but still they are doing. But can you take action? Can you put a CCTV camera in that area and then bring that area into full monitoring and control? Possible or not?
Yes, sir.
yes.
Yes, possible.
That means control is high. Maybe currently you do not have control because you are not able to see what they are doing. But the moment I can add a CCTV camera there, I can put the factor under high control. Do you understand, all of you?
Yes, sir.
So that's why,
Yes,
always the
yes.
situation has to be understood in this manner. You have to put, categorize each of these factor into one of the quadrant. And certain factors, like see here, heavy rain. What do you think? If there is a heavy rain, what do you think the impact will be?
High impact, low control.
I am giving you another information. You got a very good truck. You got a very good truck. Even if there is a moderate or a high rain, unless and until there is no much of a flood, right? You can safely transport the items and then still deliver. Now, what is the impact?
Low.
High control, low impact.
I can.
Low
So
control, high risk.
Yeah. This is how you need to understand the reality first before categorizing. Don't be tempted to decide something with assumption. Whether it is really what is the condition, right? And then you will be able to understand, right? Whether it is high impact or high control. Humidity. Do you think higher humidity will affect your packaging and the product inside?
Yes.
Then it is high
Yes, sir.
impact.
No,
Yes.
sir.
If you say yes, if you are the process owner and you say yes, then I will put it in high impact. Suppose the controllability, I can't control the humidity and all. Low control, right? So in this manner, you need to bring the factors. Now, whatever appear in this zone, red color, all of this will be,
Awesome.
taken to the police station.
Session, yes.
The next level of investigation, which is
Yes.
validation.
Validation.
Why validation is required? I already told you. Because people are not ready to agree. The project team is working, coming up with some recommendation. Hey, these are the root causes. But people around, they are not ready to agree. They are not ready to cooperate. They still have a doubt on your findings. Now you have to validate. Validate means you have to substantially prove that, yes, these are the real root causes. And validation can be referring to the existing documents. Validation can be physical verification. And if nothing works, validation can be done by conducting brand new experiments. Say, for example, I am telling you, if all the participants, they attend the training program with 100%, on the video, the kind of students or the kind of LOBs we produce will be significantly better. All of you agree with me?
Yes.
If
Yes.
suppose people don't agree, then what we do is we conduct two training programs. One training program,
With video
no
and with
condition
audio.
of coming on the camera, no condition or no requirement of interaction. People will be simply buying the certificate and going. Good sales happening, sale of certificates. On the other side, another batch where 100% on, 100% interaction, lot of opportunities for live interaction. And now we have one set of yellow bells coming from one batch of batch, and other side another set of yellow belt, coming from the what do you call another batch. Now the batch that is fully interactive, you can see a significant difference. Please note, I am using the word significant. You can always have a difference, but significant means majority of the people will agree. Then only I should use significant, isn't it? You might have read it in newspaper and research articles also. Let's say I am coming out with a new treatment for a particular disease. So far, there is no treatment available. Now they will say this new treatment can significantly, improve the patient condition, isn't it? See, if I change the treatment, and there will be some difference happening. Just because a difference happening, a treatment cannot be recommended. But if a significant improvement happens, then everybody will start believing. So only to use the word significance, we are putting some efforts. And one of the effort is conducting the experiment and then convincing the people. And now if you are able to convince people, that simply means you have validated the root causes. Now group consensus is gained, and now in the next step, we will think about taking action. Taking action on the root cause is nothing but the solution. All right. So I would like to give a stop here. So what is that we learned? Use brainstorming if you want to generate ideas in less time. Five-way analysis can peel away the symptoms so that you can see the causes. Cause and effect diagram can visually summarize the causes related to a problem or an effect. The effect is always represented by the head portion of the fish bone and head portion of the fish, and the categories of causes are represented by the subbones and the causes under appropriate categories. Cause and effect matrix is a simple tool that can help you to group the causes based on its impact and the level of control so that you can separate the potential root causes. So we just stop here for a break. Now what is the time? 8:50. So how much time you need break?
8:55.
Oh, 8:55, huh? Okay.
5 minutes, sir.
Yes, 5 minutes. No, you take 10 minutes break and come fresh. Right? 9:05 will meet.
Okay, sir.
Okay, sir. Thank you, sir.
Done.
Okay, sir. Okay, sir.
9:05 will be there.
Yeah,
Thank you.
9:05. We are in the analyze phase. We are in the process of figuring out the root cause. We know how to list the possible factor. We also know how to segregate the potential factors. While segregating the potential factor, you can use impact control matrix. At the same time, parallelly, you can, take the team opinion, the expert's opinion, and, your own common sense, use all of this. And then finally, make a list of possible root causes. And then for each of the root cause, you can try to validate, right? So validation is a statistical procedure. I will only give you an idea of what is statistical validation. I will only give you an idea of statistical validation, but I'm not going to get into the depth of the subject, which is not actually, the coming under the scope of yellow belt. But still, I would like to give you some overview. So the statistical validation is nothing but experimental validation. It's nothing but experimental validation. So imagine, let us take a simple example of experimental validation or statistical validation. We all know the cricket player Virat Kohli. Am I right? Virat Kohli.
Yes, sir.
So what is his batting
Yes,
average in cricket? What is his batting average approximately?
57 around.
How much?
57.
57. Too high.
57.
Right? Very good cricketer he is. Okay, let us take it as 55. Maybe 57 is correct, but for ease of discussion, I am going to assume Virat Kohli's batting average is 55. Now the next month, or when is the World Cup? When is the World Cup starting?
October. October.
Next month.
October starting.
Okay. So next month, the World Cup matches are coming. Probably India might play about 10 matches, right? Play about 10 or 15 matches, whatever. We need to look at the schedule. Now, what is your prediction on Virat Kohli's batting average in the World Cup? Will you be able to
570.
predict? What could be his batting average in the upcoming World Cup series?
550.
60.
550.
65.
7070.
Do you want to give a single value or do you want to give a range? Which is better?
Range.
Giving a range is better. Normally, statistical predictions are expressed in a range only. Am I right?
Yes.
If everything goes well for Virat Kohli, his average might increase. If things become tough and difficult for Virat Kohli, his average might come down, isn't it? But still you are confident that his batting average will be somewhere between 50 to 60. Can I say?
Yes.
50 to 60. So I'm typing 50 to 60 in the chat box. That means 50 is your lower confidence limit. 60 is your upper confidence limit. Understood? You are expecting or you are predicting that Virat Kohli's batting average in the next World Cup series is going to be between 50 to 60. All right. So now you want to study whether giving Virat Kohli a new coach can help in boosting his batting average. All right. Now, what is the factor we are trying to study? The factor is the addition of a new coach. That is the factor we are going to study. And what is the output? Batting average is the output. The runs scored by Virat Kohli and hence the batting average. All of you understand here Y and X? What is Y?
Batting average.
Yes, runs scored by Virat Kohli. That's your Y. But we'll use a statistics, batting average. Right. This is our Y. So Y is clear. Y is runs scored by Virat Kohli. And within bracket, batting average. We are going to use the statistics known as average. And now X is the
New coach.
new coach. The factor is the coach. Similar situation you might also come across, isn't it? Your company might be having a new marketing strategy, but they may be doubtful whether the new marketing strategy can really boost the sales or not, something like that. So these are all situations for hypothesis testing or experimental validation. Now, let us talk about this. Imagine a new coach has been appointed well ahead of the World Cup, and Virat Kohli has been trained by him for a sufficient number of period, right? And now the match is happening. Let's say the coach is a South African coach. The coach is a South African coach. He has been appointed, and for about 3 to 4 months, coaching is happening. And now the World Cup series is happening. And now, after all the matches are over, you see that Virat Kohli's batting average is 56.2. What is the Virat Kohli's batting average in the World Cup? 50?
57.
56.2. I said 56.2. Now my question to you is this addition of a new coach really helping to boost the batting average of Virat Kohli,
Yes, sir.
or is it not having any effect? Normally, what is his batting average? 55.
55.
But now what happened?
56
55 has
points.
become 56.2. Can you see a difference in the batting average?
Yes.
But are you able to give this credit to the coach?
No, it's very
It may
significant.
be sometimes due to the pitch condition,
Circumstantial.
some bowler faced.
Your doubt is more than the confidence.
Yes.
Isn't it? The doubt is more now. You are not really able to give the credit to the coach. Because even in a normal scenario, Virat Kohli has the tendency to maintain his average between 50 to 60. Isn't it? That means if the batting average, please note, average is a statistics. If the batting average can move within the confidence limits, we will not be able to give the credit to the factor. Am I right? Yes or no?
Yes.
Yes, sir.
That is what is happened right now also. 55 has slightly changed to 56.2. Now our doubt is it could have happened randomly. It could have happened randomly. That means it could have happened for reason other than the coach also. The chances are high. Chances are very high. Let me tell you another scenario. A coach has been appointed. Let's say this time the coach is from Australia. An Australian coach has been appointed. 3-4 months of rigorous coaching is given. Now Virat Kohli is playing a series. And after the series is over, you are able to see Virat Kohli's batting average somewhere here. Right? I am typing the score, Virat Kohli's batting average. And now this time I have typed 63.5. Now tell me, is the addition of the coach is helping
Yes.
to boost the batting average of Virat Kohli? Is it? Can I give the credit now?
Yeah.
Yes, sir, we can.
Now, what's the difference? The previous case and now?
Expectations.
Now is more than expectation, more than average.
Now you all have to understand the terminology.
Significant.
The 50 and 60 are known as confidence limits. 50 and 60 are known as confidence limits. If your
Confidence.
statistics is moving within the confidence limits, we don't recognize the significance. The moment the statistics goes beyond the confidence limit is like a borderline between India and Pakistan. If the statistics cross the borderline, then we understand something, is happening. That's why my statistics has gone beyond the borderline, which is confidence limit. Have you ever crossed the borderline between India and Pakistan randomly?
No.
We don't do it. There is no chance of such things happening randomly, isn't it? You can't say, sir, I crossed the border randomly by mistake while coming this side. No. And if you see any observation beyond the borderline, then the investigation is really required, or the observation is considered significant. They are not going to simply conclude that yes, it has happened by mistake. No, there is a clear intention of crossing the boundary line. Similarly, your statistics cannot go beyond the confidence limit randomly. It can go, but the chances are very, very minimal. If we say the confidence limits are 95%, then the chance for your statistics to go beyond the confidence limit is only 5%. If your confidence limits are 95% confidence limit, that means only 5% chance is there for Virat Kohli to maintain an average of above 60 on his phone. Whether coach is there or not, in spite of that, there is a 5% chance Kohli can manage to score above confidence limit. But we added a coach and we have seen the statistics outside the confidence limit. So now we want to give the credit to the coach because we are okay with taking a risk of 5%. Can you see that, all of you? We are okay with taking the risk of 5%. Right? When we are taking the risk of 5%, what does it mean? At least we are 95% confident. At least
5% or 10%, sir?
Confident that the addition of coach really boosted Virat Kohli's batting average. Yes, Neeraj, you want to ask something?
Sir, we considered 10% or 5%?
The normal practice is 5%. Unless otherwise specified, we always, assume a risk of 5%. This is known as alpha risk in hypothesis testing, which means even though you found something experimentally, still you can be wrong. Even though you found something experimentally, still you can be wrong. What is the chance for you to go wrong even after conducting experiment? 5%. All of you agree? Just because you have seen something in experiment doesn't mean that you are 100%, perfect. No. Statistics is, a prediction. Statistics is an estimation. It will have some limitation always. We need to know that. And knowing your limitation, you take the decision. If things doesn't happen, you can at least tell, hey, I already told you, 5% risk is there. That's why it is not happening. You should have a route to escape, isn't it? Right? That's called, the risk, statistical risk. And it is specifically defined as alpha risk. For any decision-making procedure, and the industrial practice is 5% of risk is permissible. 5% of risk is permissible. But you should know that you limit the risk to less than 5%. Like measurement error, I told you, you must limit the measurement error to lesser than 10%. Now this is called sampling risk. The sampling is, samples are generated by conducting experiment. That's why it is called sampling risk. So sampling risk should be limited to less than 5%. So such a procedure, such a practice is known as hypothesis testing. Is known as hypothesis testing. If you want to improvise on your confidence, probably you may have to conduct more experiments. Suppose you want to improve your confidence with respect to the same example I have told you. You have to make Virat Kohli work under the coach for at least 3-4 series. Am I right? If in all 3-4 series, Virat Kohli can score comfortably above 60, will you now believe that the addition of the coach is really, boosting the batting average? Yes. Isn't it? With the more number of experiments, the risk can go down. The risk can go down and your confidence, you will be able to decide with a good margin. So this is something about hypothesis testing, but I'm not going to trouble you with that right now. So let us move on to another interesting topic, which is correlation and regression analysis. You know why correlation regression analysis is required? Correlation regression analysis is required to understand the relationship between X and Y. So what do you know about relationship? Already while talking about Y equal to F of X, I highlighted something. Positive relationship, negative relationship. Linear relationship, non-linear relationship. What is positive relationship? When I increase X, Y will also increase. This is called positive. When I increase the X and Y is decreasing, then it is negative relationship. Why this input is required? Why this information is required? You can think about the solution. In order to think about the solution, see what is solution generation meeting? Again, it is a brainstorming, isn't it? Many people will come without any, idea about the root cause and its relationship. But you are entering the brainstorming hall or solution generation meeting with a clear idea about the root cause, with a clear idea about the relationship of the root cause with your y variable, with a very good idea about the sufficiency of the root cause. Sufficiency means number of root causes. Now, who can talk better? There are people who do not have any idea about root causes, who do not have any idea about the relationship and the output variable. They can talk better, or people who have this knowledge can talk better. Come on.
Second person.
Who have the knowledge.
Who has knowledge about
Yes, that is why we perform all this analysis before moving on to the improve phase. Because the improve phase is meant for generating solution. Before talking about the solution, we put sincere efforts to understand the criticality of the root cause or the criticality of the factor, and then the relationship of the factor, and then the sufficiency of the factor. Now, let's understand the, basic meaning of correlation and regression analysis. Correlation, regression analysis and terminology used, and few sample cases, we'll see. And now I'm showing a diagram in my slide, which is nothing but a scatter diagram. You all know scatter diagram is one of the 7 basic QC tool. One of the 7 basic QC tool. You can plot scatter diagram if your x variable and y variable both are continuous. If x and y are continuous, then only you can plot scatter diagram. X is known as predictor, y is known as response. Now tell me, I keep on changing the x. That means I'm doing an experiment. And my experiment, I continuously increase the x. Now what do you see with the y value? When I keep on increasing the x,
Is increasing.
y is also
Increasing.
increasing. That means the relationship is positive. Moreover, if I look at the way the points are, lined up, I could understand a linear pattern. Am I right? Linear means it looks like a line. So 2 things I understand. One is positive, another one is linear relationship. So I call this as perfect positive correlation. You know why I use the word positive? Because increasing the x increases y. Correlation means linear. Why do I say perfect? It's a perfect line. Can you see here? If I place a scale and then draw it, the line will pass through every point, or every point will perfectly fall on the line. Hope it is understood, right? Now, another scatter diagram. How do you call this relationship now? Perfect, negative, correlation. Why it is negative? Increasing the x.
We are increasing x and
decreasing the y.
inverse proportional.
Yeah, I call it correlation because there is a relationship. Correlation means linear relationship. I call it perfect because the points fall on a perfect line. Now, third scenario. I keep on changing the x. Y is changing, but I am not sure whether y is changing with respect to the y. The points are completely scattered. Now there is no correlation. All of you understand?
Yes, sir.
No correlation as well as no relation. Now there is a table here. This table can help you to understand the type of correlation. And before that, I am giving another diagram here. Another scatter diagram. The scatter diagram is drawn between calorie consumption. You all know calorie consumption, right? And then weight gain observed. An experiment is conducted between calorie consumption and weight gain, and the blue color dots are the experimental readings. These dots represent the weight gain. Now, what do you think? What kind of correlation it is? Come on, tell me, all of you.
Perfect positive.
Is it perfect?
Not perfect.
All the points are lying on the line?
No.
Perfect means positive.
Positive, I agree. but this is not.
Positive, no correlation.
No. We can't say no correlation. There is correlation because I could see continuously as they are increasing. Y is increasing. There is a positive relationship I can see, but the relationship is not perfect. Now since the points are not perfect, we are little doubtful, right? If you want to overcome the doubt, you can switch from using your eye judgment to using a formula. If you use this formula, you can clearly tell whether it is perfect, strong, weak, or moderate. This is the formula R. The R is known as Pearson correlation coefficient. The formula is designed in a way that if all the points lie on the line, R will become a maximum of 1. For positive correlation, it will be +1. For negative correlation, it will be -1. That means the Pearson correlation coefficient will lie between -1 and +1. All of you understand? When it becomes 1, you can use the word perfect. If there is no relationship, points are completely scattered, R will become 0. 0 means no correlation. Hope all of you understand. And now look at the table. 0 to +1 is known as positive correlation. 0 to -1, negative correlation. And within the positive correlation, up to 0.4, we call it weak correlation. 0.4 to 0.7, we call it moderate correlation. 0.7 to 1, we call it strong. 1 means we call it perfect correlation. 0 means we call it no correlation. And now you will be able to judge better. Now let us move on and see some more cases. Now tell me, this diagram, what kind of correlation it is? Is it positive?
Yes.
Now tell me, is it perfect?
No,
No.
not
No,
perfect.
No.
positive.
Oh yeah, I think it's 0.9.
Positive.
Ah, yes, 0.97 is given.
Yeah.
That means, how do you call it?
No
So
correlation.
strong.
Strong. Very good. Beautiful. So that is the usage of tools. If you learn it, you can use it. Right? This is a strong positive correlation. You can even say very strong, because it is more than 0.9, isn't it? And now this one,
Yes.
strong negative.
Negative. Yes.
Yes,
Now,
strong negative.
strong positive, you know, strong negative, you know. Now, what is this?
Poor.
0.2. So weak.
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 Minus-
Weak.
no,
Minus weak
Weak,
positive
poor.
there's still
correlation.
4.4.
So 0.255, it is coming under weak category. So weak positive correlation. And this is weak negative correlation. All
Yes,
right?
weak negative.
Weak
Weak
positive, weak
negative.
negative. And now here, what do you think?
No correlation.
No
correlation.
No
correlation.
Correlation.
No correlation.
Here,
Non-linear correlation.
wow, very good. You are right. I think who is saying, Shivani? Yeah? Who is speaking? This is
Me.
non-linear relationship. Right? So far, we were talking about linear relationship. We are measuring it with the help of R value. R is 0 here. Here also R can be 0. But visually, I could understand a non-linear relationship. R is 0 means no correlation, no relation. Here also R is 0, but the meaning is different. No correlation, but there is non-linear relation. And the non-linearity is parabolic.
Parabolic.
Yes, parabolic.
Very good. So this is this is about correlation. Now imagine we have a small exercise. Yeah, any question?
No, sir.
Okay. So imagine we do an experiment or an exercise. We are monitoring the weight gained by an individual. Weight gained by an individual for different levels of stress. We advised an individual to consume 1,500 calories every day in a particular week. we noticed that he has not gained any weight. So when he is consuming 1500 calories, the weight gain is nil. All of you understand?
Yes.
Same manner, next week, 2300 calories, but there is some weight gain noticed. So likewise, several weeks experiment was conducted. We are trying to understand whether the calorie consumption has a significant relationship with the weight gain or not. All of you understand how the experiment is conducted, how data is generated. Now, we go for the correlation analysis. Correlation analysis, you all know there is a formula. The workings to arrive on R equal to 0.97, I have given in the Excel file. You can see that. You can understand, right? So R equal to 0.97. What is this telling you? What is this telling you? The relationship is positive and it is strong. That means if the individual, whenever the individual increases the calories, we have observed increase in the weight. You can see in the graph, I mean in the data also. According to the data, whenever calories are increased, the weight gain is also increased from 0 to 200 gram to maximum. How much weight gain we have seen? 1100 grams of weight we have seen. Right? That is what is confirmed by R equal to 0.97. R equal to 0.97. Strong positive correlation. Now I want you to understand one more thing, R square. You remember I told you R square, which is now known as coefficient of determination. So you need to square the 0.97. So what happened? 0.97 multiplied by 0.97 is 0.94. Now the 0.94 is letting us understand. The 0.94 is letting us understand that 94% of the variation we have observed in the weight gain are due to the changes we have made in the calorie consumption. You should be able to frame this statement on your own by listening to me. So 0.94 means 94% of the changes observed in the weight gain are due to the changes we have made in the calories. All of you understand the meaning of my statement?
Yes, sir.
That means the weight gain solely depends on the calorie consumption. 94% is not a small number, isn't it? 94% of the weight gain are because of the changes in the calories. This is a prediction based on the experiment we have conducted. Please note. This is a prediction based on the experiments we have conducted. Since R square is 0.94, we are now making a conclusion. You know what is the conclusion? For that particular individual, calorie consumption is the single root cause for the fluctuation in his weight. How many of you understand the conclusion? We have done an experiment for several weeks. You see here, look at the data. So many weeks you have done an experiment. After conducting the experiment for so many weeks, you are making a conclusion. That person weight can fluctuate only if the calories are changed. Only if the calories are changed, then only his weight is going up and down. There are other factors. But during the study period, all those other factors did not fluctuate. Right? That means he is in a good control with respect to all other factors. That the suspect factor is only calories, because he knows some days he is taking food in house, and sometimes he has to take food from outside, and the calorie levels here he is not very sure. So he doubt that he has poor control over the calorie consumption. And now it is experimentally validated. Can you see here? Now it is experimentally validated. That means the calorie consumption is the single root cause for the weight gain for the particular individual for whom we conducted the experiment. This is very, very important. We can't, apply this prediction or apply this finding for other person. Other people, we are not sure. Hope all of you understand what I'm speaking. Right?
Sir.
So now the same thing, is visually shown. This is called a scatter diagram. So now what I want to show you is, see, you don't have to do all these calculations manually. And one thing I have already shared is an Excel file, Excel template, using which you can calculate the Pearson correlation coefficient. Another method is I'll show you a software which will be extremely helpful, and it is worth learning that software. And that is nothing but a software known as Minitab. That's a software known as similar to Excel, but it is much more superior than Excel. And this is specifically meant for Six Sigma projects. What is this? What is the name of the software? Minitab. So let me open it and show you how it can be helpful to you. Yes, it opened. So now I can show. Can you all see my screen, Minitab screen? Yeah.
Yes.
Yes.
See, this area looks similar to Excel. This area is known as worksheet. This area is known as worksheet. Here you can copy paste your data or you can type your data, right? So now calorie consumption, weight gain. Can you see the data? Yes. Now for this data, I want to plot some graph. So I have an option here, graph, scatter plot. Now this window is coming. I choose the simple scatter plot. Okay. Now it is asking me which is your y variable. Now tell me which is y variable, weight gain is y variable or calories is a y variable?
Weight gain.
Weight gain is y variable, calories is x. After declaring y and x, I am giving OK. Can you see a scatter diagram here immediately? Yeah. Do you understand something out of it right now?
Yes, sir. Yes, sir. Positive.
Yes, sir.
Yes, I understand positive relationship, and it is more or less linear. More or less linear.
Yes, sir.
In order to say whether it is strong or weak or very strong or perfect, I can calculate R value. So go to stat,
Value.
go to basic stat. There is something called correlation here. The description also automatically appears. This correlation will measure the strength and the direction of linear relationship between two variables. It is only measuring linear relationship. Only if you know it is a kind of line, you can use this. So now this window is coming. Now you need to select the variables. Two variables together. Click select. I give OK. Now can you see R equal to 0.97?
Yes, sir.
Yes, sir.
0.97.
So what do you understand? R equal to 0.97 means? First of all, it is positive. Relationship is positive. First of all, it is positive. Another thing
Positive
is
correlation and very strong.
positive
Positive relationship.
and
Very
relationship is
strong.
very strong relationship.
Very strong.
And when I calculate R square, which is 0.97 multiplied by 0.97, it becomes 0.94.
94.
What it means? 94% of the changes observed in the y variable are due to the changes made in the X variable. Very, very useful statement. I'm going to copy this. Copy this. I'm going to paste it. Now, Y variable, in the place of Y variable, I'm going to type it. What is the actual Y variable in my study?
Weight gain.
Very good.
Right.
Weight gained in grams. Weight gained in grams, right? So 94%
Yes, sir.
of the changes observed in the weight gained in grams, I remove this, are due to the changes made in the
Intake.
calories consumed in calories. All of you understand? Do you think this information is helpful for you?
Yes.
That means
Yes, sir.
calorie consumption is a strong influencer of the weight gain. Am I right?
Yes, sir.
Is a strong influencer of the weight gain. So if you want to optimize your weight gain, you just have to optimize the calorie consumption. That's all. 94% of the problem can be solved now. Only 6% of the reason for the variation in the weight gain, we are not able to understand through this experiment. Still 6% of the variation we are not able to understand. Please note. According to the experiment, we have understood this much. Now you take action on the calorie consumption, you will see results happening in terms of weight gain. Am I right? You increase the calorie consumption, your weight gain will go up. You decrease the calorie consumption, the weight gain will go down. That means you will start losing weight. So this is true with respect to the individual with whom we have done the experiment. And all the conditions maintained during the experiment has to be maintained during your validation also. Clear? Now, one more example before we wind up for the day. See here, there is a foundry. We all know foundry, right? Where people melt the metal, pour it in a die, and then make products, metal products, plastic products. So many products are coming, right? So it's a foundry. In that foundry, the products are known as castings. Products are known as castings. In castings, one big problem is porosity. You know what is porosity? There are some holes inside the casting.
Blowhole.
Yeah, blowholes. You can't see it visually because it is inside, but with some kind of testing, NDT testing or something, you can really understand. Now the brainstorming is done, YY analysis done, fishbone diagram done. Now experts and everyone is suspecting that the porosity is caused by hydrogen content in the molten metal. All of you understand the context now?
Yes,
If
sir.
the amount of hydrogen content is present in the molten metal is the cause for porosity problem. So an experiment is conducted. Now, how will you conduct the experiment? You keep changing the hydrogen content. You see here, we kept on changing the hydrogen content, and parallelly we measured the porosity. Now I want to understand whether there is a relationship between them. Scatter plot. Simple scatter plot. Now my Y variable is porosity. X variable is hydrogen content. I give OK.
Hydrogen content.
Now do you see any relationship?
No relationship.
No.
Very difficult to judge. So let us do the correlation analysis because R value will come. Stat, basic stat, going to correlation.
Correlation.
Now I remove this two. I take this two, hydrogen content and porosity.
Hydrogen.
I give OK. Now look at my R. R is how much?
0.625.
0.625.
0.625. That means it is weak,
Moderate.
moderate or strong?
Positive.
Moderate, moderate.
Positive and
Moderate,
moderate.
Sir, moderate.
positive,
Hmm.
correlation.
Positive correlation.
Okay. And now I want to find out R square. What is R square? 0.625
0.6
multiplied by
into
0.625.
And 3, 4 or 3, 6.
Now how much it is? 0.39
3, 6,
something.
0.3.
R square is 0.39. My coefficient of determination is 0.39. That means same statement. Let me copy the same statement.
39% of.
So I copy the same thing. Now this time this is not 94%, 39% of the changes observed in the
Porosity.
porosity or due
Porosity.
to the changes made in the hydrogen content.
Hydrogen.
So what do you understand now? Hydrogen content is not a strong influencer.
Possible.
Hydrogen content is one of the influencer. Do you see the difference in the statement? That means it's one of the root cause, not the only root cause. It is one of the root cause and not the only root cause. Because my R square is very weak. Can you see here?
Yes, sir.
Now I have to, now what should I do? I have to include additional factors. I have to include additional factors. Why I have not included additional factor? I made a mistake in impact control matrix, or I made a mistake while creating my fishbone diagram, or while conducting the brainstorming. People have not thrown light on the other cost factors. Somewhere I made a mistake. Now that is reflecting in my R square. Can you see that, all of you? If you are not, conducting the brainstorming sessions properly, if people are not, really participative, if they are not throwing enough light, you may end up making a mistake, isn't it? You may end up missing some important factors. In such cases, that will get reflected in your experimental results. Please note. And with the help of the tool R square, you can figure out whether the quality of the analysis you have done is acceptable or not. For any analysis phase to complete, R square must be at least 80%. If R square is not even 80%, you are not supposed to move on to the next phase. What is the next phase? Improve. Don't think about the solution. You have to include additional factors and reconduct the study till the R square becomes 80%. And then you think about the solution. You will be able to solve the problem. All of you understand?
Yes.
Yes, sir.
Okay. So that's all about the analysis phase. Now we know how to find out the root cause. We also know a way to find out how much contribution the factor is making into the problem, isn't it? How do we understand? With the help of the R square. So now we have got another 5 more minutes. Maybe if you got any questions, you can ask. And those of you who are seriously interested in enriching your understanding further, we have the green belt batch commencing next Saturday. Next Saturday, sorry, not next Saturday, 14th October, the Saturday after the coming one. So you can plan, and now you are in the best condition to take up the green belt program because you have all basics well set, isn't it? You know what will happen in define, measure, analyze, and so on. And tomorrow you will also learn, much more on improve and control, and preferably a small case study also. You might see the complete flow. And so if you could, in this condition, if you could listen to the green belt modules, you will be able to better connect. And you can be much more productive. Yes. So yes, we have batch in, if October is difficult for you, then you can explore November. Right? The earlier is better. You know what happened? The more the time you take, the tendency is to forget. So before you forget, you can upgrade, right? That is the idea. And see, the belt level is a proven roadmap. Well-proven roadmap in preparing you to become a very good leader. In yellow belt, the requirement is, you are working under the project leader. In green belt and black belt, you will be working as a project leader, right? And the moment you upgrade to black, you become a full-time improvement agent. You become a full-time improvement agent. You know, one Six Sigma project can save several lakhs. Imagine you doing 2 projects, each project making a saving of 10 lakhs annually. Now, what is the annual saving you are giving to your company?
20 lakh.
20 lakhs saving. If company knows that your presence can add 20 lakhs to the company, they can pay you better. 10 lakhs is a very, very small amount, I'm telling you. Much more is possible, right? Easily 40, 50 lakhs savings can happen from each and every single project, right? So this is only an example I'm telling you. A black belt will be doing 6 improvement projects in a year, assuming 10 lakhs or 20 lakhs per project. So 6 projects, the saving you can deliver to a company is, can run in terms of crores, correct? 20 lakhs into 6, 1.2 crores savings. Now your company can definitely pay you much more better, isn't it? So that's how Six Sigma bells are considered special. They're always asset to the company. But the point here is, you should not end up simply buying a certificate. That is not going to be helpful. You really have to learn the subject, also experiment it initially, and after a couple of efforts, you will really start delivering results, no matter what kind of project it is. And we are ready to back you up, right? We are not going to disconnect right after the training program. But you have to, take steps and try to apply and then seek for the help. Yes, we will certainly come to help. Right? And if you come up to the master black belt level, and it is very, very sure that we ourselves can get you a lot of opportunities. Even in our own activities, we can give you the opportunities to involve in training as well as consulting activities. We have a lot of requirement, but you need to go up to that level. Okay. So any other question, any other point? Now define is done, measure is done, analyze is done.
Okay.
Any free version of Minitab available? Yes, Minitab is always available free for 30 days. 30 days trial version is available. You can initially use that and then you can switch to cloud version and later on you can buy it. Right now, learning purpose, you don't have to buy. You can rely on the trial version. But all that we do in Minitab, we can try to do in Excel also. Excel also has got the capability. Excel also can plot graphs, but it's not that much user-friendly like Minitab. That's the difference. Okay. So any other specific question you would like to ask? Green Belt course is 4 complete days. 4 complete days. There also the basics will be taught, but you can focus on the additional learnings. 4 days, 2 weekend, but that will be really intensive. Okay. So model question paper for what? You want model question paper for yellow belt? We have taught you much more than the yellow belt requirement. You can crack any exam now, provided you have, listen to us carefully and make note of, some important points. The questions are going to be, definitely very, very simple. How to apply for green belt? You just send a message to the same person who admitted you in the yellow belt. Or otherwise, you can send a message to me. I'll do the needful for you. I am also there in the same group. Right? So, I have to, maybe I think Nishak Sa. All right. So, any completed project? Yes, probably tomorrow we will try to show you a small case study. But yellow belt, since the time is limited, we only show the cases tool wise. A complete project we certainly show in green and black belt. But let me check whether tomorrow we can show it. All right. So if there are no questions, and again, it's a very, very suitable time for all of you to upgrade your understanding green belt. So don't delay too much. And don't worry about the yellow belt exam also. You can do extremely well. I'm very, very confident. And all the best. And see you tomorrow. Question pattern is only MCQ pattern. 25 questions will be asked. You need to score 60% and above. That's all.